Now that you understand how HVC assembly instruction works, let's move on to the HVC assembly instruction. So among the three individual exception generating assembly instruction, the HVC instruction is also important because it is a core part of the virtualization system. Because in the virtualization system, the guest OS is to be communicating with the hypervisor. For this, the HVC assembly instruction is mainly used. Now, let's look at how the HVC instruction is executed. HVC assembly instruction is called hypervisor call. In practice, many of the system software engineers call HVC as hypervisor call. And just like HVC assembly instruction, HVC is the exception generating assembly instruction. So if you run any of the arithmetic assembly instruction, the parent counters move to the next address. But as for HVC assembly instruction, the parent counters move to exception handler, exception vector address at exception level 2 by switching exception level. This assembly instruction is mainly used by the guest OS to request service from the hypervisor. As you know, then it will switch the exception level from exception level 1 to exception level 2. Now let's look at this diagram that indicates the execution flow of HVC assembly instruction. As you can see, there are two separate the operating system. But in the world of the hypervisor environment, we can call the separate operating system the guest OS. Here is the guest OS 1. So here, what you can see is the guest OS 2. So in the automotive sector, so guest OS 1 is running in the cluster, and another guest OS 2 can be running as the navigation. So this kind of the virtualization system is widely used in automotive sector and cloud server. Okay, moving back to the main topic. So let's look at how HVC assembly instruction runs at exception level 1. As you can see, so RTOS kernel in the guest OS 1 and Linux kernel in the guest OS 2 can perform HVC assembly instruction. When running HVC assembly instruction, the ARM core will perform two tasks at the same time. The first thing does is to switch the exception level from exception level 1 to exception level 2. And then the parent counter will be branched to the exception vector address specified by this kind of rule, the convention. That is, this the 0x400 that is offset will be added to the value of VBAR EL2 system register. This is a way to calculate the exception vector address when the HVC assembly instruction runs at exception level 1. As you know, unlike another arithmetic assembly instruction, the HVC assembly instruction will generate exception. So every time you look into the HVC assembly instruction, and you have to think about this kind of workflow.